Alright, so throughout this term or semester, you guys are going to be having to convert from one unit to the next. Now, in physics, typically we'll use kilograms for our mass, we'll use meters for our distances, but we're not necessarily always given those distances. We might have that measurement in another format, like grams or kilometers, something like that, and we're going to have to convert it. Now, one way that we can remember very, very simply is to go from these using basically by sliding the decimal point. Okay, we have this acronym, King Henry died while drinking chocolate milk. We use that to remember our prefixes in the metric system. K, H, D, D, C, M. And so K is kilo, H is hecto, okay, D is deca. The next D now is smaller, deci, centi, and then milli. Okay, and these all stand for a larger or smaller unit of measurement. Again, a kilo is times 1,000, a hecto is times 100, a deca is times 10. Okay, and actually I should write this down here. Okay, deci is divided by tenth or 1/10. Centi is 1/100th, and milli is 1/1000th. Okay, now our base units are right here in the middle, and again those are grams, meters, or liters, and then we just simply move our decimal point one way or another. For example, if I'm in lab and I measure, let's say 250 grams, okay, in physics we don't use grams very often, we need kilograms. So if I'm going to go from grams to kilograms, I'm going to move from my base 1, 2, 3 decimal places over. So I'm going to go ahead and do that here. 1, 2, 3. So if I'm going to go from 250 grams, I should have 0.250 kilograms. If we do one where we move from the other way, let's say I am in lab and I measure 157 centimeters. We don't use centimeters per second for velocity, or we don't typically use centimeters for distance. We need to get to meters. If I'm going to get to meters, I'm going to move from centi to 2 spaces to the left. 2 spaces to the left. So 157 centimeters is 1.57 meters. A couple examples there. Now again, you're going to have to let your units be dictated by what equations we're looking at, okay, because there are standard units of measurement, but typically speaking, when we talk about distance, okay, we want to be in meters. When we talk about mass, we want to be in kilograms, okay, because if we use a different unit of measurement, typically speaking, our equations won't work out correctly. Okay, so that's the very simple version of common units of measurement. Now, we can take this a step further, okay, because it actually goes quite a ways. Now again, if I'm going to a larger unit, it's just like we did before, where it's deca, okay, hecto, and kilo. Again, moving the decimal place to the left. Now, again, if we go to the right, we have deci, okay, centi, and milli. Okay, but it goes much further than that. Okay, for example, if we're talking about going much, much larger units, we have things like gigabytes. Okay, giga meaning, what is that, times 1,000? Or 1,000 times a kilobyte. So that means that that's times 10 to the 6. There's 6 spaces. So 1, 2, 3, 4, 5, 6. This is going to be giga. Okay, and then those of you that are familiar with computers, if we go another step larger than that, or actually, I'm sorry, that's megabyte. Okay, if we go further than that, okay, computer people know we go to gigabyte. 1, 2, 3. Again, mega is times 10 to the 6, giga is times 10 to the 9, And then even larger than that, actually, if you buy real expensive hard drives nowadays, they come in terabytes, which is times 10 to the 12, T-E-R-A. Okay, so if I want to go from my base all the way to here, I'm going to move my decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. Okay, and again, we can go the other way if we go smaller than that. For example, much smaller than a millimeter is a micrometer, 10 to the -6. So this is 10 to the -3, -4, -5, -6. So this would be micro, and that's times 10 to the -6. Okay, or 1/100,000th. Okay, if we keep going smaller than micro, we'll get to nano. Okay, and nano is times 10 to the -9, and then even smaller than that is pico. Okay, and that's times 10 -12. Okay, so there's your stair-step ladder to go all the way from your base. You could potentially go up to pico and tera. Now, realistically speaking, in physics, we're going to be staying within these units of measurement here. Okay, but I wanted you to be aware of the things like micro, nano, pico, or mega, giga, and tera. That's unit conversions by using the decimal slide method or within our metric system. The other post that we'll be making will be one on how to convert from using the factor label method.